All right, good afternoon. Welcome everybody to the Building Lightning Components Deep Dive session. My name is Rodrigo Rebocas. I'm a Senior ISV Technical Evangelist here at Salesforce. Before we start, Salesforce is a publicly traded company. Please make all your purchasing decisions based on public and current available functionality only. All right, so here's our session agenda. So we're going to start talking to you guys and showing you all the different types of Lightning events available on the Lightning Components framework. Right? All the different types of events, all the different interesting things you can do with these events from a developer perspective. Then we're going to talk about Lightning-based components, which are these awesome building blocks of user interface that you guys may be used to with Visualforce, with the Apex tags. So Salesforce is making more and more of these amazing building blocks out of the box in the Lightning framework, and we want to show you how that can speed up your custom Lightning components development as well. Then we're going to talk about Lightning Data Service, which is a very new, cool addition to the Lightning Components framework, which basically, if you guys are used to Visualforce, it puts a standard controller inside a Lightning component, so you can basically create a custom Lightning component without a single line of Apex code fetching data from the Salesforce org and performing CRUD operations on that record. And finally, we're going to talk about a cool technique whenever you have a parent Lightning component and creating child Lightning components inside of it, which is how to create these child components dynamically from code. Okay, so let's start off with a quick recap of the Lightning Components framework. Right? So Lightning Components are these loosely coupled application modules that you guys as developers create, and your admins put them on a Lightning page, maybe with other Lightning components that other developers create, maybe with some other Lightning components that they install from the App Exchange, right? So this is a different type of development if you guys are used to Visualforce, where you're used to own the entire page, right? Because this allows for a very plug-and-play development approach. So if you think about it, because you're creating parts of an application, your admins can basically mix and match your Lightning components with other Lightning components and create a very customized applications, right? Instead of you guys having to rewrite an entire Visualforce page for a different audience inside your companies, right? So somehow these small applications with the Lightning components on a Lightning page, they need to work together, right? So that brings us to the first topic on today's session, which is how does communication work between these Lightning components, right? So the answer to this question is through the use of Lightning events. So you guys as developers, you use Lightning events to basically share data and communicate between Lightning components on a page or inside a parent Lightning component through the use of different events. And you also use events to respond to user interface events or Lightning components framework events that the framework is firing. Okay, we're going to take a look at more examples. And you also use events to navigate, to take the users to some places in the Lightning experience in Salesforce Mobile. Under the hood, Salesforce, whenever you interact with one of our standard CRM components, we're firing these Lightning events to take the users to different Lightning pages, to take the user to Visualforce pages. So you guys as developers, you guys can use these type of events as well. So if you guys look here at the monitor, this is an illustration of a Lightning event that is fired by component A, and the framework then distributes these components to all Lightning components on a page, for example. Okay? So just a visual representation of how that works. It's basically a messaging system inside the framework. So when we talk about events in the Lightning framework, it can be a little confusing because there are actually 5 types of events. So we have browser events, we have system events, navigation events, component events, and application events. All right? And for today's session, we're going to use a custom Lightning component that my team has created here at Salesforce, which is a custom ListView. Okay? And here's the architecture. So we have a parent Lightning component, which holds the header of our ListView, and it holds the column headers, and it holds that new button on the markup. And inside this parent component, we create different instances of this child Lightning component called ListViewRow.cmp. Okay? So when we render our Lightning component, it looks something like this. Okay? So I want to show you guys a little bit of the code behind this to show you the approach that we use to create these Lightning components. So first, here's our recruitment application that we use for demos with customers like you guys. And here is our ListView Lightning component here on the top left. Okay? So I want to show you guys the code behind this. So let's go to our ListView.cmp components markup. Okay, here, this is the markup of our parent component. Remember, the one that holds the header. So I want to scroll down the markup here and show you guys how we create the different child component instances in our case here. So if you guys are used to Lightning component, you may have seen this tag aura iteration. If you guys are from the Visualforce world, this is the same to Apex repeater. So basically, this tag allows you to loop through a list of records that you probably fetch from the Salesforce server. And then on each iteration of that loop, we basically create this ListView row component instances. So that's how we're creating the rows inside our parent. Okay, and the reason why I'm showing this approach is because later on in the session, I'm going to show you another approach. All right, so now let's go back to our deck, because I want to talk about the first of those 5 types of events of the Lightning Framework, which are the browser events. So browser events are basically a notification regarding an action, and they are triggered by user interaction with an element on your component, right? So this is not particular to the Lightning Framework. Every web technology stack has and uses browser events. And here's an example, right? So this is an HTML table header, and here we added a browser event handler on click. So basically, whenever the user clicks, if you guys look here at the monitor, whenever the user clicks on the header in our list view, we invoke that sort grid action in yellow there on our parent's controller to basically use JavaScript to sort our grid, right? To sort our list of child components inside our parent. Okay, so browser events are pretty trivial. I'm not going to spend a lot of time on that. I do want to start talking about system events. So system events, they are fired by the Lightning Framework during Lightning Components lifecycle. Okay, so they indicate a component state. Okay, so you guys as developers, it's important for us to be able to identify a state on a Lightning Components lifecycle so we can do a lot of different interesting things. So here is an example of 3 system events that are fired by the framework in this particular order whenever a Lightning component is created, right? So the init event, the render event, and the after render system event. For today's session and for our example here, we're going to take a look at this render event and how we use that for our use case. Okay? But first, it's important for us as developers to know where to look for the documentation of which system events we can handle, right, in our custom components. So I want to go here to my org, and I want to show you guys that if you go to your the Lightning Components Developers Guide, and if you use this search box here and you search for system events, you will get to this page here, system events, which is loaded here. And here we have a grid with all the different system events that ourselves as developers can handle and do a lot of interesting things here. So we have, for example, done waiting system event that indicates that an app is done waiting for a response from a server. We have value change that indicates an attribute value has changed in our custom component. And we have the value init or init event that you guys may be used to. It's on all the Lightning Components start training modules. And we are going to use, in our use case here, I'm going to show you how we use this aura value render event, which indicates that our component has finished rendering in the HTML DOM for our requirement. Okay? So I have actually isolated our ListView component on its own tab here, ListView, so it's easier for us for the demo. So we got a requirement from our project manager, right? They said, okay, whenever our ListView component first initializes, we want the first row to be selected by default. So our development team got together and we say, oh, I guess we can use a system event, right, to be aware of when our component finishes rendering in the HTML DOM, so we can maybe apply a CSS class to that first row, right, and make it look like it's selected. So we went through that documentation that I showed you guys. I saw that value render event, or render event, as you see in code, is the one to use. So I want to show you how we did that. So let's go here to our Lightning Components, parent Lightning Components code. Okay, so if you look here at the top of our parent components markup, we have a handler, this aura handler tag, which means that we want to handle the render system event, or aura value render. Okay, so whenever we handle that event from the Lightning Components framework, we execute this JavaScript action called onRender, which lives in our parent component local controller. So let's take a look at what we're doing there. So here is onRender. So basically, inside this onRender JavaScript function, we instantiate a variable and we use component.find to find the HTML DOM node of that first child component that we want to make selected by default by its aura ID, which is row 0. And then we use a.u2.add class to add to that HTML DOM node this specific Lightning Design System CSS class SLDS is selected. So we use this technique to add that CSS class dynamically to our first node, to our first child component. And that's how we end up with the first row selected by default. So that's an example of how we use system events for this use case. And now let's talk about navigation events. So navigation events, they basically enabled components interaction with the Lightning experience and Salesforce mobile experience. So whenever you guys are using the Salesforce CRM, when you click on that added button, for example, you notice in the Lightning experience that we open a modal where the user can make changes to the field values, right, for the record. So you guys, as developers, you guys can take advantage of the same events that we use on Lightning experience on our platform to open kind of the same modals from your custom Lightning components code and make the user experience even better. Here are some examples. So force navigate to URL is a navigation event that takes the user to a new tab in the Lightning experience. Maybe you want to open an external website, or maybe you want to take a user to a Visualforce page. And force added record and force create record, they are these special navigation events that open the added record modal and create new record modal. I want to show you guys, how many of you guys are aware of Aura Docs? Can you raise your hands? Great, great. So Aura Docs is a very cool tool, very handy for us as developers. Inside your developer orgs, if you open up a new tab, and after the force.conf part of the URL, if you put Aura Docs, and we can use this anchor tag reference, this very cool Lightning application, documentation application opens up on your org with the documentation that is available for you to, with all the things that are available on the Lightning framework for you to use as developers, okay? So we have this navigation bar here on the left, and we got the requirement from our project manager to open up that standard record edit modal whenever the user clicks on that new button on the top of our parent component. So we started looking at these namespaces here under the Aura Docs events, and we found this standard navigation event here called force create record, okay? And if you look at the description, it's an event fired to show the full record create panel, which sounds like exactly what we needed, right? And if you look down the list of attributes that we need to set in code before firing that event, it looks like there's only one required attribute, which is the entity API name. Basically, in order to open that modal, we need to pass to this event the name of the object, the API name of the object that we want to load the fields inside that standard modal from the Lightning experience, right? So let me show you how we did that in code. So I'm going to go back to my parent Lightning components code, and let's go to that. So since we identified the event that we want to use to open the modal, I want to show you the button, right? The new button markup. So here's the new button. Whenever the user clicks on that new button, we execute. We have this browser event handler that executes this create new record action on the parent Lightning components controller. So let's take a look at what we do there. All right, so create new record, here it is. All right, so basically, since we identified the standard event that we want to use to open up that modal, we basically grab the object API name from that we want to use to load fields on that modal, and then we instantiate, we use a.get to basically instantiate that force create record navigation event that we just saw the documentation page into a variable, right? And after doing that, we use component.setParams to set that only required attribute that we had to set before firing that navigation event with our object API name. And then as soon as we fire this navigation event, magic happens, right? The new object modal opens up whenever we click on this new button. So you guys can do this from your custom components right now and make your user experience even better, right? So let's go back to our deck. Here's an example. And now let's talk about component events. So component events are useful whenever you have this nested components hierarchy architecture, right? We have a parent and we're creating child components inside our parent. So component events are useful whenever you need to integrate or send an information from the child Lightning components in your hierarchy to the parents in the hierarchy. So they can be handled whenever a child component fires a Lightning component event. They can be handled by the component that fired itself or by any parent in our hierarchy. So we actually got a requirement from our project manager. And let me show you what that was. So he said, okay, so you guys, when you create the list view rows, we want to have this option here, basically this button menu group, and we want the user to be able to remove the rows from our list if they don't need it, right? So you notice that we have the option to remove it here. So our development team, we got together and say, okay, that's the perfect use case to use Lightning component events. Because remember, this button menu group with those options, with the option to remove, lives on the child components markup. So, and we know that the parent is the one that will have to remove the list row at some point, right? So basically, we want to bubble up a communication from the child component to the parent component. So we made use of component events for that. Let me show you what we did. So let's go now to our ListView row component, right? Our child component, which represents a row in our list. And then I want to show you guys that we register at the child components level that we were going to fire this bubbling action event of type list row bubble action event. So what is that, right? So let me show you the markup for that. So here it's a custom Lightning event that we created of type component. Again, perfect where we need to bubble up information in the hierarchy. So we created 3 different attributes inside this custom Lightning event. So we want to notify from child to parents level the record ID that was selected, the child action. Remember, we had view, edit, and remove. So we want to know which action the child component sent. And we want to check what's the index row of the child that the user clicked on remove, right? So if we go back to our list view row, to our child's components, we basically have a button menu group, and we have those 3 options, right? So whenever the user selects one of those options, we execute this browser event handler, handle list menu click on the child component's local JavaScript controller. So let's take a look at what we're doing there. Okay, so handle list menu click. So basically, here, we grab, basically we know that we had 3 attributes that we need to send from child component to the parent component, right, using that bubbling event. So we grab the record ID, and then we grab the index row, and then we analyze with a switch statement, JavaScript switch statement, which action the user actually chose on that button menu group. So if the action that he chose was remove, we actually instantiate that bubbling action event that we just saw the markup, and then we start setting. We use component.setParam to start setting those 3 attributes values. So record ID, the action, which is remove in this case, and the index row. And then we fire this Lightning component event or bubbling event. And now it's going to bubble up to any parent components in our hierarchy, right? So let's take a look at what happens on the parent component side. So here is listview.cmp. Notice that it has an aura handler that it's going to handle any of these bubble events that any child components inside this parent fires with this type of list row bubble action event. And whenever a child component bubbles up information using that event, it's going to execute this handle bubbling action JavaScript action on the parent's JavaScript controller. So let's take a look what we do there. So handle bubbling action. All right, here it is. So basically, whenever we receive a bubbling event, on the parent component's JavaScript controller, we grab the parameters. So we grab the 3 pieces of information that the child component sent to the parent. And then we basically have a switch statement to take a look at if it was a remove action, for example, that the child sent, right? So if it was, we now use list.splice, so it's simple JavaScript list.splice, to basically remove that child list view row from our parent. So that's how the list, the rows end up disappearing from the parent. So this is an example of how we use component events for that. And now let's talk about application events. So application events are very useful whenever you guys need to pass information from one Lightning component to another Lightning component, but they do not live on the nested components hierarchy scenario, like it was the case with the list view rows and the parent. Basically, if we need to integrate or pass informations between Lightning components that live on the same level, they can live inside the same pair at the same level, or they can even be different Lightning components on the same Lightning page. You can use application events for that. And application events, they follow a publish-subscriber model, meaning that one event fires that application event, and only the Lightning components that actually subscribe to the same application event will be able to handle it and receive the information that comes inside of it. So here's an example, like component A fires this event X application event, and notice that only components B and E on this Lightning page actually subscribe to that same application events, but not components D and E, right? They're not subscribing, so they don't know anything about that. So let me show you guys how we use the application events for our use case here. Let's go to our code. Back to the org. I want to go back here to this page, which is our interviewer console page, Lightning page. So now our project manager asked us, okay, that's great. We built our ListView custom component, but we want this ListView custom component to be integrated with the other Lightning components that we drag and drop on the same page, which are this Twitter Explorer and this referrals Lightning component, right? So the ask that we got, the requirement that we got is that whenever the user clicks on any rows here on our custom ListView, we want the other Lightning components on the page to refresh with the contextual information for that candidate. So you see that for Rodrigo, Twitter Explorer now refreshed with his Twitter information and his referrals list. And same thing happens with lists. So since these Lightning components live on the same page, they're not parents of each other, we knew that we needed to use Lightning application events for this communication. So let me show you how we did that. So if you go to our list view row, we basically, we started talking, the development team started talking, we say, should we create a custom Lightning event for this type of communication? Because we just basically need to broadcast a record ID, right? It's a pretty common use case. Most likely Salesforce already created a standard event for that. So what we did is we went to our Aura Docs application. And inside events, we started looking and we found this LTNG namespace. And we found this select as object standard application event that Salesforce has created. And when you look at the description, it sends a record ID when an object was selected in the UI. So that sounds exactly like our use case. We can make use of this standard event instead of having to create a custom Lightning event for that. And it looks like it only has one required attribute, which is the record ID, right? And it has one other attribute, which is channel attribute, basically an identifier of which Lightning component is firing this event. So let me show you how we use that. So back to our list view row. As soon as we decided that we could use that application event, we basically added a handler. We basically added an Aura register event to identify that we're going to fire this application event of type LTNG select as object at some point. And then remember that the user is clicking, it's a row. Our list view rows, it's basically an HTML table. So inside this HTML table row, this TR tag here, we basically added an on-click browser event to identify whenever the user clicks on the row, right? So let's take a look at what happens on this action on our child components JavaScript controller, fire row click events. All right. So fire row click event. So basically here, we basically use JavaScript, so this dataset.record, to grab the ID from the HTML node whenever the user clicks on that table row. And then we instantiate that standard application event, LTNG select as object, into a variable. And then we use component.setParams to set the record ID attribute with our record ID that was clicked, and with an identifier on that other channel attribute. And then we fire this application event, and now we know that only the Lightning components that are actually subscribing to the same application event type are going to be able to receive this information. So if you guys may recall, we had a Twitter Explorer Lightning component. So let me just give you a quick example of what happens on that side. So here's the Twitter Explorer component markup. Notice that it has a handler to that same LTNG select as object event. And whenever it handles it, it executes this handle application event action on its own JavaScript controller. And then I'm not going to go into a lot of details of what that does, but basically that makes a call to an Apex class, which ultimately makes an API call to the Twitter API and brings back to the Lightning component the Twitter information for that candidate. All right, so that's an example of how we use application events for this use case. And now let's talk about base components, right? This is one of my favorite topics since I started developing with the Lightning framework. We didn't have a lot of these building blocks available at first, but now Salesforce actually has made available over 80 of these building blocks, okay? So it has never been easier and faster to create custom components, because these building blocks, so think of an avatar, or think of a checkbox label, or a button menu group, right? Those are basic building blocks that Salesforce is making available already with the Salesforce Lightning Design System styles, and with JavaScript, with data validation, with some of them with data binding out of the box. And you guys can access them through code using the Lightning namespace. So how do I know which of these base components are available for me to start using now, right? So if we go back here to our browser, I want to show you guys that you guys can look at the list, at the full list that is currently available, and also at the Lightning Components Developers Guide. If you want a quick search for base components, you will get to this page that basically has a list of these different building blocks that are available for you guys to use inside your custom Lightning components. So we have accordions, we have tab set, layout, which is our grid system, which is responsive, button, etc. I just want to point out that a very cool new one just became available with Winter 18, which is Lightning Data Table. If we click on that, you'll get to the documentation page that gives you a code snippet on how to use it, how to create a data table really easily, with some examples how to make use of the events that it fires. So this data table has column resizing, has column sorting all over the box. So as you guys may imagine, my custom component that I was showing you guys, our ListView, actually it has a data table inside. So if this base component was available about a year and a half ago when I created that custom component, I would have taken 1/10 of the time to create that. So you guys can start making use of these base components now to speed up your development. I want to show you here on our list, because what we used inside that custom list view was another base component called Lightning Button Menu, right, for that drop down on each list view row. So we basically copied this code snippet, and we knew how to handle the event, the menu select event. So just to illustrate that, when we go back to our list view row, I want to show you that we use exactly that for that case where we had the options to view, edit, and remove. So here it is, Lightning Button Menu. We were able to create that button menu really easily and fast by using this base component. All right, so let's go back to our deck, because I want to talk about Lightning Data Service now. So Lightning Data Service, it's one of the coolest additions to the framework, to the Lightning Components framework. And funny enough, it's another Lightning-based component called Force Record Data. It doesn't render any UI, but basically when you reference this component inside your custom component, you're basically making a lot of good things available inside your custom component. The first thing that I mentioned is it puts something similar to an Apex, to a Visual Force standard controller inside your your custom Lightning component, so you don't have to fetch data. You don't need to create an Apex class at all to fetch data from the server and perform CRUD operations, okay? And the second benefit is that whenever you reference, when you use Lightning Data Service that force record data, you basically, you are tying up your custom component to our new shared record cache that is available on the Lightning Experience in Salesforce Mobile. You guys have noticed that on the last 2 releases, the Lightning Experience became really fast. One of the reasons was because of our new shared record cache functionality. So the idea is that different components, the standard components that Salesforce creates, and your custom components are all looking at this intelligent shared record cache. So whenever the user makes a change in one of the standard CRM components on your own custom components that use data service, all the other components on the page can actually receive that data change without having to make a trip to the server every time. So here's an example. So this field change is made, and then it writes to the browser cache. And then our custom component here, because it's using Lightning Data Service, it receives that record change without having to go to the server. One other very cool benefit that we're working on for a future release, is currently in draft, is the Lightning Data Service. Because it uses shared record cache, it enables a Lightning page to be fully functional whenever you don't have internet connection. So because we're working with the browser cache and this intelligent shared record cache, all the Lightning components, the user can basically work on a Lightning page, on all the Lightning components. And whenever the internet connection is back up, we have a smart sync technology that basically commits that modified data to the Salesforce org. And this is something that we also have with the Salesforce Mobile SDK. So I want to show you guys an example of how we use Lightning Data Service in our demo here. So let's go back to our org here. Now I want to load this candidate record detail page in our recruitment application. And I want to show you a new requirement that we got from our project manager. So our PM said, OK, let's build now a custom Lightning component that basically prints out a graphical representation of the different interview scores that a candidate has had. Right? And we want that to be very fast, and we want this chart to basically redraws itself if the user makes any data change on the Salesforce server. Okay? So what we did is, let me show you the code behind this. So this Lightning component is called candidate score. Okay? And we used basically chart.js. This is a third-party framework to draw the chart. There's also a base component, which is a chart component on the roadmap. So just so you guys know. So what we did here is, inside this chart component, we added the force record data base component, which is basically the Lightning Data Service. And we're specifying some attributes here to retrieve data from the shared record cache. Basically, we're passing the record ID that we grabbed from the extension here. Force has record ID to the Lightning Data Service. And then on this layout type attribute, we're specifying that we want to fetch the data for all the fields that the candidate can see based on his page layout assignment. Okay? There is also another attribute in case you guys want to put the names of the fields that you want to retrieve the Lightning Data Service. This is just a quick way of doing that. Okay, so once our custom component is using Lightning Data Service, let's make a code change here. Let's change the technical interview score on this standard component from 80 to 10. And let's save the record. And notice what happens to the chart component once we save the record, because they're all looking at the same Lightning Data Service or shared record data cache. So let's save that. And notice that our chart redraws itself because it's looking at that same shared record cache. So by using Lightning Data Service, you are not only making your components more performance better because you're running things from the shared record cache, but your user experience is also getting better with this cool automatic UI refresh. Right? So let's go now to talk about this technique of dynamically creating child Lightning components inside a parent whenever you have this parent nested components hierarchy scenario like we have with parent and child components. So sometimes if your Lightning components are very complex and you have to create multiple child components inside a parent, it can be useful, especially if you are a developer, to create the child components. Instead of using that RI iteration tag that I showed you guys in the beginning, creating child components on the parent's markup, it may be very useful to use this approach. So you would create the child components inside the parent component's JavaScript code dynamically with JavaScript, and here you would have code level control of the different child components that need to be created. So you can, for example, add if statements to create child components with different attributes once you are inside the JavaScript code. So you get a lot of flexibility, and another implied benefit is that you are not, since you are creating things dynamically, you are not loading the entire DOM tree of all those child components when you create them from the markup into your custom components overall HTML DOM tree, so you're making the performance better as well. So this is an approach that I would recommend you guys to take a look in our Lightning Components Developers Guide if your Lightning components are becoming too complex and if you have this nested components hierarchy scenario. I have actually pasted our session deck. If you go to dreamforce.com using a web browser and you look for our session record page for today's date, you see a chatter feed at the bottom, and I just pasted a deck. Here are some links, so if you guys click on 1, 2, 1, 2, 3 here, you get to the documentation pages of the things that we talked about on today's session, as well as the Lightning Components roadmap page, which is public. And also, notice that there is a GitHub code repository that you guys can take a look at this ListView Lightning component that we showed on today's session. You can fork it, make it your own, and let us know what you build with that. I'm not sure if we have much time left for Q&A, but I'm happy to take any questions here on the side. Thank you.